Now, much like with everything in this unit when it comes to systems, there's plenty of ways to solve these problems. I'm not going to be showing you every single method because that's just going to be an overload to you. I'm only going to show one particular method. If you do independent research, if you Google this and you find a different technique that you like, use it. But I'm only going to show one. And that method is substitution. I think it's the safest and least ugliest way. You can use elimination for these problems, but you might end up with fractions, decimals. It's a big headache. So we're going to take a look at how do we solve nonlinear systems using substitution. Let's refresh our memories on the technique of substitution. So recall, solving systems via substitution requires at least one equation to look like x equals stuff or y equals stuff. You want one equation where one variable is solved for. If that's not true, you'd have to manipulate the equation. You'd have to rewrite the equation. You typically want to solve for an equation whose coefficient is either positive 1 or negative 1. Again, you don't have to follow that suggestion. If you want, you can technically solve for any variables you want, but if you don't follow that hint, you may run into fractions, and I know how much you guys love fractions. But other than that, if I ever give you a system that has like exponents, x squares, y squares, don't freak out. It's the same algebra. It's the same technique of substitution. Let's do a quick example here. Well, quick might be a strong word. Let's do an example here. Say I wanted to solve x squared plus x plus 36y plus 34 equals 0. And x plus 3y equals negative 2. That's a scary looking system. Oh my goodness, lots of variables. I have an x squared and an x. I don't know what to do. You could use elimination. We're going to stick with substitution. The first thing I want to do is I want to solve for a variable whose coefficient is 1 or negative 1. Now, I'm going to ask a very obvious question. We have two equations here. You don't have to highlight. I'll erase it. We have the top equation and the bottom equation. Can we agree the bottom equation is easier looking? So I'm going to focus on the bottom equation. Of these two variables, x or y, what would be the easiest variable to solve for? X. So that's my technique. I'm gonna focus on the easier equation and solve for the variable that doesn't have a visible number in front of it. So working with the bottom equation, we get x plus 3y equals negative 2, and then I'll go ahead and subtract the 3y. So x equals negative 2 minus 3y. So far, so good. Nothing too crazy, nothing too out of the ordinary. Now here's the idea of substitution. You're going to take this whole equation, negative 2 minus 3y, and you're going to plug it into the equation that we didn't use, namely the top one. So in the top equation, wherever I see an x, I'm going to change it to a negative 2 minus 3y. So I'm going to take the top equation and substitute. Negative 2 minus 3y squared plus negative 2 minus 3y plus 36y plus 34 equals 0. And then all you got to do is do math. Now, if you forgot from Algebra 1, well, how do I simplify a square? We all know, I hope, squaring means multiply something by itself. So I'm going to do some scratch work over here. So this is my scratch work. To do the first piece here, squaring means write it multiply by itself. So I'm going to write it twice. And then all I'm going to do is repeated distribution. Some people like to call it FOIL. I call it repeated distribution. So negative 2 times negative 2 is a positive 4. Negative 2 times a minus 3y is a positive 6y. I've ran out of stuff in the second parentheses to multiply, so then I'll distribute the second term. Negative 3y times a minus 2 is a positive 6y. Negative 3y times a negative 3y is a positive 9y squared. And then you go ahead and combine like terms. 9y squared plus 12y plus 4. So that's what belongs in the first term here. So this first guy right here is equal to 9y squared plus 12y plus 4. You guys see how this second parentheses here, there's nothing in front of the parentheses. There's nothing multiplying it, so I can just drop the parentheses. Those parentheses aren't needed. So I have a plus a negative 2, which is a minus 2. A plus a minus 3y is a minus 3y. And then copy down the 36y plus 34 equals 0. Let's clean them up a bit by combining like terms. 9y squared. So what like terms do we have? We have the y's here. So I have a 12y minus 3y. I have a 36y. So that's going to be, what's 45 plus 45y. And then plus 36 equals 0. And then all you have to do is solve it. It's a quadratic equation. Hopefully remember from Algebra 1 how to solve a quadratic. We have quadratic formula, we have factoring, so on and so forth. No, we have a 4, 2, and a 3. Yeah. Yep. Be smart. Yeah, we can go ahead and dive into this problem and solve for it, but those numbers are pretty big. What do you notice about all those numbers? They're all multiples of 9. So we could solve it as is, or let's make life simple, make the number smaller. If we can, go ahead and do that. Divide both sides by 9 to make the number smaller. So we have y squared plus 5y plus 4 equals 0. Now that is a much easier problem to solve. Right? So again, think back to Algebra 1, solving quadratic. You can factor it. You can use the quadratic formula. Negative b plus or minus b squared, all that fun stuff. But this guy ends up being factorable. Y plus 1, y plus 4. So now that we've factored it, set each piece equal to 0. So you get y equals negative 1 and y equals negative 4. This is the only difference between nonlinear systems that we've done compared to the systems of linear equations that we've been doing for like a week and a half. When we solve the equations that we have been doing for the past week and a half, we always got one answer. Y is this one number, x is this one number, z is this one number. In this case, it's actually possible to get 2 x's, 2 y's, 2 z's, whatever. So how do I solve this? What you do is you treat it one at a time. So normally, think back to yesterday or the days prior, the moment you get a numerical answer, what do we typically do with this number? Substitute it back in, plug it back in. So what changes when I have 2 variables? You're going to plug them both back in, but one at a time. So I got 2 answers, 2 y's, y equals negative 1, y equals 4. So let's use negative 1, y equals negative 1, and we can plug it into any of the original equations. Not a trick question. Which equation might be smart to use? The bottom one, because it's a heck of a lot easier. If you want to have a good time, if you want to live life on the edge, go ahead and plug into the top equation. I'm going to take the safe route and plug into the bottom equation. So the bottom equation is x plus 3y equals negative 2. So wherever I see a y, plug in a negative 1. X plus 3 times negative 1 equals negative 2. X minus 3 equals negative 2, x equals 1. Then I'll go ahead and do the same thing with the y equals negative 4. Plug in a y equals negative 4. You get x plus 3y equals negative 2. X plus 3 times negative 4 equals negative 2. X minus 12 equals negative 2. Add the 12 over, x equals 10. Okay, I did all this. Hey, Mr. Vo, what's my answer? I got all these numbers here. I'm so confused. What you want to do is you want to remember the linkage. this answer of negative x equals -1 is linked to this answer of y equals -1. This answer of x equals 10 is linked to this answer of y equals -4. You don't want to mix and match them. So you go ahead and write your answer as a coordinate, x comma y. So my answers is 1 comma -1 and 10 comma -4. So for these nonlinear systems, it is possible to get more than one answer. That's the only real big difference between today's problems and the problems you've done before. The algebra is a little bit more advanced because, hey, you know, it's algebra 2, but the idea is the same. Substitution. Take one equation, the easier one, solve for a variable, plug into the other equation, and solve. That's basically it. Any questions? Questions, comments, concerns? I feel bad just leaving you with just one example. So let's just do one more together, and maybe we'll fast forward through this a little bit if you guys get the idea. But hey, you know, having more examples never hurt. So let's just do one last one. If there aren't any other questions, we can just move on to the practice. But you know what? I'll do a super duper ugly one. Let's do, this is a good ugly one. -4x squares plus 3y squares minus 27x's minus 3y's minus 62. When does it end? Right here, equals 0. And then x minus 3y equals 2. Step 1, solve for a variable. Gee, I wonder what equation I'm going to work with. Let's work with the top equation. Kidding. That's a horrible idea. The top equation is ugly. Let's use the bottom equation. It's nice, neat, and simple. X minus 3y equals 2. So I'm going to solve for a variable. X is pretty easy in this case. So I'm just going to add the 3y over. X equals 3y plus 2. That means in the top ugly equation, wherever I see an x, I'm going to change it to a 3y plus 2. So we have -4 instead of x. I have 3y plus 2 squared plus 3y squared minus 27 instead of an x. It's parentheses 3y plus 2 minus 3y minus 62 equals 0. Whew. That's a lot. So for this part here, again, just do what I did in the previous part. Just use the scratch work, write it out twice, and then distribute. Can I just go ahead and fast forward to the result? You guys understand about repeated distribution, FOIL? Okay, so I'm not going to show it, but you basically do the same thing we did in the scratch work on top here. So just do the same thing. You should get something like -4 times 9y squares plus 12y plus 4 plus 3y squared. And here in this case, there is something in front of the parentheses, so I can't drop it, I have to distribute. So distribute the -27, you get a -81 minus 54 minus 3y minus 62 equals 0. So go ahead and distribute this -4. So we get -36y squared minus 48y minus 16. I'm not going to do anything else to the other part of the equation, so I will drop it down. Question? Oh, thank you very much. I forgot the y there. The other part of the equation I'm not going to touch. I'm just going to copy down. Plus 3y squared minus 81y minus 54 minus 3y minus 62 equals 0. Combine like terms. So let's see. I got some y squares here. I got some regular y's. And I have constants. So we're just going to combine all of those together. -36y with the positive 3y squared is a -33y squared. Let's move on to the blues. -48 with a -81 with a -3 what's that? 51, negative 132? I hope someone's double checking my mental arithmetic. And let's do the constants, the orange numbers. What's that? Negative 60, 70, so negative 132? Okay. That's an ugly looking problem. The numbers are pretty big, so I'm going to ask myself, can I reduce it? Is there a common number I can divide out? And the answer is yes. It turns out we can divide everything by negative 33. What luck. So that gives us a positive y squared, a positive 4y plus 4 equals 0. It's not always going to work out that nicely for us, but hey, I'll take it when I can. And then you just solve it again. Solve it by factoring, solve by quadratic formula, whatever method you want. This guy ends up being factorable. Y plus 2, y plus 2. So then you set each of them equal to 0. Y plus 2 equals 0. Y plus 2 equals 0. And then you go ahead and solve. Y equals negative 2. Y equals negative 2. In this particular example, I got two y's just as before. But they're the same number. So in this instance, if you ever get multiple variables, but they're the same number, you don't have to do twice the work. Just do it one time. So I really only have one y value, y equals negative 2. So using y equals negative 2, you plug it into any of the original equations. And again, I'm guessing a lot of us, if not all of us, will choose the easier route. And I won't judge you for that because I will do the same thing. So x minus 3y equals 2. Plug in the y value. X minus 3 times the negative 2 equals 2. So that's x plus 6 equals 2. Subtract the 6 over. X equals negative 4. That x equals negative 4 is linked with that y equals negative 2. So there's my answer. Negative 4, comma, negative 2. So I only got one answer this time. Question? Oh, yeah. Yep. So if these nonlinear systems, you may get one answer, you may get two answers. You would get one answer if the variables give you the same number. You don't have to write it twice. You can just write it once. Yep. So that's it. That's just the extra layer I want to add for today. The technique of substitution should be the same as what we've been doing for the past week and a half. The only difference is the problems are a little bit harder because they're nonlinear. I'm going to be tossing some exponents in there. Okie dokie? Right. That is it. That is 3-5. That is the end of the first half of this unit.